they went to failure, you'd think they went to a max effort. So we started wondering whether or not people were rating their discomfort as opposed to their effort, and this led on to a lot of research that we've done to try and differentiate effort from discomfort. And it's led me to think a little bit more carefully about what do we really understand about effort and the role it plays in exercise, physical activity, both in the sense of how does effort influence, or you know, how do we perceive, what influence does exercise have upon our perceptions of effort? What influence can perception of effort have upon our exercise behaviours, both in terms of our choice to actually engage in exercise and our choice to continue performing that exercise, and also in the sense of how do we adapt to that exercise. So I've been thinking very carefully about how do we define effort, how do we differentiate it from other confounding variables, and coming up with appropriate definitions from a scientific perspective that will enable us to then move on and have better research to try and answer some of these questions. So obviously the kind of discomfort thing and the differentiation between effort and discomfort, that's quite well settled as far as I'm concerned. We've shown in a number of studies now that the two are differentiated. There are studies that have used kind of spinal analgesia to basically block afferent feedback, block the perception of discomfort, pain, or any sensation coming from the legs to the brain for you to interpret as pain or discomfort, and yet people who have had that done can still perceive effort when they're trying to do tasks, trying to perform cycle tasks or an isometric knee extension or something like that. So we know that that effort seems to be something that's centrally generated by the brain, not something that arises from the feedback that comes from the muscles that are working. And so we think it's related to essentially the signal from the brain telling your muscles to essentially to recruit muscles to meet the demands of the task. And so I'm coming towards this definition of effort in relation to the demands of the task. And so we look at effort in the sense of the actual effort required to meet the demands of the task, and then also think about your perception of what that is as something separate, because there's every possibility that your actual effort required could not, or your perception could not match up with that actual effort. And in fact, we've got some experimental data that suggests that might be the case. And we think that might be why, for example, people are very bad at predicting how close to failure they are, and this is where some of the practical implications start to come from it. Not only is effort differentiated from discomfort, if we study it carefully, but it's also different from how heavy something feels as well. Now, of course, in reality, most of the time the weight will influence the effort, because if we pick a heavy weight, we have to try harder to actually do it. So the actual weight, as opposed to how heavy it feels, will influence the effort required. But all of these things, I think, are needed so that we can come up with the right tools to actually measure effort properly and differentiate it from these other components. So from a practical perspective, we've been very interested because we've done a lot of work looking at the role of train to failure and things like that. And I think you spoke with James about the study we did with our colleagues in Germany, Jürgen Giesing, looking at how good people are at predicting reps to failure. And we've also done a few studies with Jürgen where we had a group, for example, train to failure, and a group stop what they thought was 1 rep short of failure. And we seem to consistently see that the group that went to failure has better adaptations. So we wondered whether or not really stopping 1 rep short of failure is that different from going to failure, or whether maybe they're stopping further from failure than they think they are. And so that first prediction study, we got people to say how many reps do you think you could do, and then we got them to do it, and we found that they underpredicted. But there's an issue, a limitation with that, because of course if you ask someone before the exercise, they've not got all the kind of gestalt feedback that you have during the exercise that might help you with your predictions, and you can't actually perceive the effort throughout the exercise to think, how close am I to max, and sort of make those predictions. So we've just finished up, it's not published yet, a deception study where we did 2 experiments with this. We got people to come in and we spoke to the participants and said, what we're doing is we're doing a reliability study. We wrote a paper, and we talked about different set endpoints in this paper. We talked about training to failure, and we talked about training to self-determined rep max. And so what we want to do is follow up from this study and see, how reliable are they as set endpoints. So we got the participants in on 4 different occasions for both of the studies. In the first one, we got them to do a first condition where we did a 1RM, and we took 70% of their 1RM. Then they came in 4 conditions, randomized order. 2 of them were self-determined rep max, so they were told, we want you to keep going until you think you'll fail the next rep, and then stop. So don't fail, stop on the one you think is the rep prior to failure. And then the other 2, they actually went to failure. And as far as they were concerned, we were comparing the 2 self-determined rep maxes together and the 2 failures together. But what we were actually doing was comparing the 1 rep short of actual failure in the failure conditions to the self-determined rep max conditions.
Awesome.
So we did that, and the first experiment we did, we did find that people underpredicted. They underpredict by, actually, interestingly, a similar amount as we found in the study with Jürgen. But we were a little bit worried because, of course, we tested their 1RM on one day, and then they came in on 4 separate days. So maybe on one day they were feeling a bit stronger, so it wasn't really 70%. Maybe on that day it was like 65, 60%. Maybe one day they were fatigued, so the 70% load was really more like 80. So instead, we repeated the study and got them to come in, and at the beginning of each session, we did an MVC, maximum voluntary contraction, on the Med-X knee extension, and then we set the weight for that day. So every time they come in, they were always using 70% of how strong they were on that day. And we thought, look, if the first lot of study results were just because of that day-to-day variation, then in this study we'll find there's no difference, that they're pretty good at predicting. We actually found that they were worse in that study. So it suggested to us that people are not very good at predicting how close to failure they are. Now, this one was quite realistic in that we didn't tell them to differentiate discomfort or anything like that. So I suspect that maybe that's because, unless instructed properly, people anchor their effort perceptions on how uncomfortable the exercise feels. But we've got another study, interestingly as well, which I think suggests a discordance between the actual effort required and the perception of effort. Because if you kind of hypothetically think about it, if you say, right, I'm going to give you 70% of your 1 rep max, and you had kind of like a graph with percentage of your 1 rep max here, and then another y-axis with your effort level, the line for 70% would go like that, and if you've got time on the x-axis. So every rep you do, it's always 70% of your 1 rep max. But what will happen is your relative ability to meet those demands will decrease from max as you fatigue. So eventually you get to a point where because of fatigue, your relative ability to meet the current demands of the task matches and then do no longer meet the demands of the task. And what we should see, hypothetically in this model, is effort should increase sort of linearly up to that point from 70% initially up to 100% at max. So this is how we're kind of thinking of actual effort. So in this sense, we had a study that Paolo and colleagues did with a different aim, but I recognised an opportunity to look at the data to answer a question about how good people are at matching actual effort to their perception of effort to their actual effort. So in this study, they had participants doing maximal velocity squats, and they were looking at velocity loss, which we spoke about. As you fatigue, velocity will reduce. And so they had people do essentially one condition where they did sets to failure and one condition where they stopped after they had lost a certain percentage of velocity. And so what we were able to do was take the failure conditions and say, how much velocity did they normally lose? Like, what's the max velocity they could lose? And then for all of the non-failure conditions, how much of that total velocity loss they could. Yeah, so essentially what percentage of fatigue did they have? Because that should, in theory, correlate with their effort if they're matching their actual effort and perception of effort well. Now in this study, we asked them to differentiate effort and discomfort, so we knew that we were measuring effort, not effort marred by discomfort. And no matter how you cut the data, there was no relationship between the actual effort based on the velocity loss and the perception of effort that they gave in the submax sets. So I wonder whether or not humans are just really bad at submaximal perceptions of effort, and whether when you hit failure, you of course hit a ceiling, and once everyone's at failure, you know that's max. But in between nothing and max, there is a discrepancy between the actual and the perceived perception of effort.
It is a hard, if you think about it, even if you're experienced, like and you come in like today on new equipment here, it's very hard to predict how many reps you'll get or how close, and like, you know, if I'm here with you guys, for example, and I get that extra hit of motivation, actually, you know, that can keep moving a little bit longer than even a season training can perceive.
So I think there are a lot of implications, there are wide-ranging implications from looking at things in this kind of sense. So I think the definition of effort is important if we're to understand what role it might play in you know, behaviours and adaptation. So from a behaviour sense, I mentioned that dual mode theory earlier. That's based around effort, and if you go to high effort, then people get a negative affect, and if you go to a low effort, you get a positive affect. People like light, easy exercise, people don't like hard exercise. But that was all done using traditional rating of perceived effort scales. So for all we know, data could be saying people don't like uncomfortable exercise. They do like exercise that's not so uncomfortable. So I really want to start now taking our definitions and redoing some of that research and finding out whether or not it's actually the discomfort or it is the effort. Because this then comes back to what we were saying about like
light load, heavy load stuff.
Yeah, absolutely. We know light loads produce higher discomfort. So now I almost want to use that as a model to then look at heavy and light loads' influence on affect. Do people consistently rate, because if we go to failure, we know they're both max effort.
Totally, both max effort,
Exactly, so if people rate higher and more negative affect for the low loads, that's probably because of the discomfort, not the effort.
Yeah.
So that's interesting.
Then from a motivational perspective, in general, give people heavier loads.
Exactly, yeah. And even more broadly, when we then think about, come back to the moderate vigorous, maybe it's not surprising that people aren't very good at figuring out what moderate and vigorous actually is, because submaximally, people aren't very good at matching actual and perceived effort. So we start to maybe understand why people's behaviours are quite hard to influence, and it gives us a way of thinking, okay, what can we do to try and influence them? On the other end of the spectrum, when it comes to the adaptation, the stuff that we're kind of interested in, the trainers are interested in, and people in this community are interested in, at the moment, we don't really know whether or not you have to train to failure or not to maximise adaptation. We don't have enough data on the role of effort in a kind of dose-response way. For all we know, there could be a threshold where once you passed it, going any further doesn't make any difference. But we've actually not got any studies that have really looked at that. I suspect that there may well be a threshold, but based on what we're starting to see around people's submaximal effort abilities to kind of like perceive effort submaximally, we might just end up finding it doesn't matter. We can't identify it anyway, and that actually practically just training to failure is probably the easiest thing to do. All we know really at the moment is that training to a higher versus a lower effort, higher wins out. But I think it's going to help us move forwards towards figuring out whether or not there really are these thresholds and that kind of thing as well. So I think all along that, a better understanding of effort will allow, a more scientific understanding of it will allow us to kind of figure out a lot of these kind of big questions, I think.
Awesome.